Welcome, dear students. Let's continue with what we have already started. Now, we have started, or rather, I have given you the formula for your chapter number 21. Now, name of the chapter is a bit long. I'm not going to read it, but in simple word, let me call it just trigonometrical identities. Okay, so yesterday I gave you these formula to be noted down. Okay, so I hope you have noted down these many formulae. Now, with the assumption, let's begin the first exercise, and I'm taking from exercise 21a, question number 3. Okay, so question number 3 says, prove this. Now here, basically what you need to remember is you have to have good knowledge of these formula, okay, and you have to have good observation skill as well. For example, in the left hand side we have tan and cot, but in the right hand side we have cos and sine. So basically you want to change tan and cot into cos and sine. So this can be done, that tan can be changed into cos and sine if I use this formula, isn't it? Now the same happens if I use cot, for cot A if I use this formula. Okay, so as I have said, I have done the same thing. So tan can be written as sine by cos, and cot can be written as cos by sine, and in the middle we have plus sine. Now in the denominator, if you see here, this entire thing is addition of two fractions, and for that what you do is you take the denominators LCM. So LCM of cos A and sine A will be sine A cos A. Okay, now when you divide this LCM by the denominator cos A, you get cos A and cos A gets cancelled, so sine A is left. So sine A into this sine A numerator becomes sine square A. We have plus sine, isn't it? Now divide this denominator by sine A. Sine A and sine A gets cancelled, so what is left? Cos A left. So this cos A multiplies with cos A and gives you cos square A. Now this is a very important formula, as you can clearly see here, which says sine square A plus cos square A is equals to 1. In place of theta, you can have any other angle. Okay, you can write A, if you can write B, you can write alpha, you can write beta, whatever you want to write. Okay, so in that case, sine square A plus cos square A is 1, and here also we have got sine square A plus cos square A, isn't it? So how much is this then? This is equals to 1. Okay, now this will invert itself and goes to the denominator, so 1 into this entire thing becomes sine A cos A, and that's what we wanted to show, isn't it? So this is my right hand side. So you may pause the video and note down the solution. Let's have a look at this now. Here we have sine to the power 4a minus cos to the power 4a is equals to this much. So let me take the left hand side. Now can I write this in this way? Yes, because this sine square a whole square is nothing but sine to the power 4a, and the same happens with this as well. Now let me treat sine square a as a, okay, and cos square a as b. Then this becomes a squared minus b squared, isn't it? And we know that this is a square minus b squared is a plus b into a minus b, and for me a is this entire thing, that is sine square a, plus what is b? B is cos square a, so cos square a into a minus b. So a plus b into a minus b is written. Now again, you know this, isn't it? So that's why the value of this first part becomes 1. So 1 into this one will remain as it is. Okay, so we get sine square a minus cos square a. Now in our proof, what I want to show is I don't want cos square a here, isn't it? So I don't want cos square a. So again, I'll use this formula only. Okay, it's the very same formula, and from here what will be cos square a? This sine square a goes over there, so cos square a will be 1 minus sine square, isn't it? So instead of this I've written 1 minus sine square a. So open up the bracket, so minus into minus becomes plus, so sine square a plus sine square a is 2 sine square a, and we have minus 1 also, isn't it? So that's what we wanted to show here. So this is my right hand side. You may pause the video and note down your solution. Let's have a look at the 7th problem, which says prove this. Okay, so it's quite simple, so let's not waste time. So here, you know, the common is here also we have got cos to the power 4a, and here we have got cos square a. So basically cosec square A is common, isn't it? So when you take cosec square A, you have out of 4 you have got just 2 left, isn't it? And since this thing is kept outside, now we don't have anything here, so we'll just write 1. Okay, now let's have a look at this formula. Okay, follow the arrow. Let's apply this formula. From here we see that this is cosec square theta, isn't it? So cosec square theta is 1 plus cot square theta, isn't it? That is cosec square A can be written as 1 plus cot square A, isn't it? Okay, now what happens to this? Let's see. Let's take this minus over there, so it becomes cosec square theta minus 1, isn't it? And we have cosec square A minus 1. Now this will be equals to cosec square theta minus 1. From here will be equals to cot square theta, isn't it? So that's why in place of this I am writing cot square A. Now your job is very easy. You just need to open up the bracket by multiplication. So cot square A into cot square A is cot to the power 4A plus 1 into cot square A is cot square A. That's what we wanted to show here, isn't it? So this is my right hand side. So you may pause the video and note it down. And one more thing, here you cannot show like this. Okay, so I have shown using the arrow, but here you will write the formula. Okay, you will mention the formula as we have done in the earlier problems. So pause the video and note it down. Let's have a look at this problem now. Question number 9. So it says left hand side is this much, so we need to prove that this will be equals to 1. Okay, now pay attention. See here, this cosec A is there, isn't it? Can I write this cosec A as 1 by sine A? Okay, so this is sine A, remember? Can I write this? Yes, because we know that cosec theta is 1 by sine theta, isn't it? Okay, so 1 plus cos A is not changed. Now cosec A, again it can be written as 1 by sine theta, isn't it? And cot A can be written as 1 by tan theta, or wait, we are converting everything into sine and cos, isn't it? So this is sine A. Yes, 1 by sine A. Here we have got cos A. Cosec A is 1 by sine A. Cot A in terms of sine and cos is this much. Okay, so instead of cot A, I am going to write cos A by sine A. Okay, so that's what I have done. See, cosec A is 1 by sine A and cot A is this much. Okay, now let's simplify. So 1 into this will remain as it is. In the denominator we have sine A. Now here what happens is LCM is sine A, okay, and when you simplify the numerator you get this much. Divide sine A by sine A, you get 1. 1 into 1 is 1, minus again sine is divided by sine is sine A. I'm sorry, 1 into cos A is cos A. Okay, now see here carefully. A plus B, A minus B, isn't it? In the numerator we have A plus B, A minus B, where A is 1 and B is cos A. So your answer will be A square minus B square. So A square means 1 square, so 1 square is 1 itself, minus B square. So cos A square is cos square A, divided by sine A into sine A is sine square A. Okay, fine. Now again let's make use of this formula. So from here let me take this cos square A over there. So you get 1 minus cos square A equals to sine square A, isn't it? So that's why the value of this will be sine square A, and in the denominator we have sine square A. Both of them gets cancelled, so you get 1, and that's what we wanted here, isn't it? So you may pause the video and note down the solution. Okay, so next we have this one. So I am taking 13. So here in the left hand side we have this one, isn't it? Okay, now see here very carefully. Can I write this as cot square as cos square A by sine square A? Can I do that? Yes, definitely I can do that. Okay, now if you see here, if you simplify this, for example, here actually in the denominator we have 1, isn't it? So LCM of sine square A and 1 will be sine square A. So divide this LCM by sine square A, you get 1. 1 into cos square A is cos square A, minus is there. Okay, now in the denominator we have 1, so divide sine square A by 1, you get sine square A itself. Okay, because whenever you divide any number by 1, you will get the very same number. For example, when you divide 4 by 1, you get 4. When you divide 10 by 1, you get 10. Similarly, whenever you divide sine square a by 1, you'll get sine square a. So sine square a into cos square a is sine square a cos square a. Now in the numerator, is there anything common? Can you see? Yes, cos square a is common. So cos square a is common means from here only 1 is left. Minus from the second term, we have only sine square a left. Again, you know, this is using this, how much? If you use this 1 minus sine square a will be cos square a, isn't it? Okay, so that's what I'm doing here. So instead of this, I'm writing cos square a. Okay, so this cos square is kept separately. Okay, because we want cos square a also in our proof. Okay, now cos square a by sine square a. Now you know that cos a by sine a will be cot a, isn't it? So that's why using this formula we have, this is cos by sine is cot, but square is also there, so that's why we'll put square, that is cot square a. That's what we wanted to show. So you may pause the video and note down the solution. Let's have a look at the 14th question. Okay, so you might be wondering, why am I going so fast? Because there are many problems in this particular exercise. I think there are 40 problems from this exercise. Okay, so we will try to cover many problems in one class itself. Okay, so this is given to us. So if you look here carefully, this is cos a plus sine a into cos a minus sine a, that is a plus b into a minus b. Yes, if you treat cosec a as a and sine a as b, then this becomes a plus b into a minus b. And you know that this is a square minus b square. A is cosec a, so that's why a square will be cosec square a minus b square, that is sine square a. Okay, now I'm going to make use of this formula. Okay, because see, I want cot. Okay, and from cosec square, will I get cot square? Yes, we will get the cot square also, right? So if I make use of this formula here, then I'm going to use this formula here as well. Okay, so let's see what do we get. So cosec square a can be written as 1 plus cot square a as per this formula, and sine square a can be written as 1 minus cos square a. Open up the bracket, so the sign will get changed. Minus 1 and plus 1 gets cancelled, so you have cot square a plus cos square a. So that's what we wanted to prove. So this is my right hand side, so you may pause the video and note down the solution. So your homework, do any 5 sums out of these and send it to me. Thank you very much.